So the count is coming correct, but the problem is format and the order. So how do you print a dictionary? You will say, I'll go through each key. I'll say for key in frequency. Okay. Again, that key is dummy variable. It can be anything. You can put K, T, H, whatever you want to say. I am writing key because it's easier to read. And when you go to the projects, remember to write like this. Use big variables, even in your placement rounds and so on. Okay. We have seen many students got placed because they used correct variable name. Otherwise, what you all like to do, A, B, C, D, E, F, G, it'll go till T, L, M, N, O, T, and all. So till Z it goes 26 variables. Then you ask, what is this C variable doing? Sir, I don't know, sir. Right? Because for one thing, for one formula, you would have used one variable. Right? Good names for your variable. Okay. So anyway, for key in frequency, I'll print the key. I'll use F strings here, and I'll print the key, and I want to print. Then we'll look at the format here. So I'll print this, and I want to print the value of that key. So how to do that? I'll say frequency of key, like this. Okay. Now when I run it, I'm printing this list also, which I should not be printing. Right. So I'll just, this we did just to see. So I'll just remove this part. Right. So as you can see here, it's still not the correct answer. Why? Over there it's printed in some other order. What order is printed there? Alphabetical order. Very good. So now how do I print it? Sort. So how do I sort it? So this is another thing. If you do dot keys like this, right, what will I get? You'll get all the keys. This is also not a problem. The problem is, so we'll just print this once again. Let's just print frequency dot keys, just so that you understand what you get out of this. Okay. So what you get is, you get a list of the keys in a sense, right? So what I need to do is, I'll say frequency dot keys, I'll say sorted. I believe this will work. 1 second. Let me just say, yeah, sorted frequency dot key. So we're saying whatever the keys are coming, but give that to me in sorted order. Now why it was able to sort it even is because these are all alphabets. So there is some sorting order for alphabets. Okay. If it was some other thing which can't be sorted, then you have a problem. But here it's possible to be sorted. So when I run it, it works, and when I submit it, this also works. Okay. Did everybody understand this one? All right. So now we'll go to the questions I gave today. Let's look at the question, distinct number in Windows. Open it up while this one loads. Open it up, distinct number in Windows. Okay. So what is that question, distinct number in Windows? The question is, you're given an array of n integers, right, and an integer k. Return the count of distinct numbers in all windows of size k. See if you can. All right. So let's look at the example. 1 2 1 3 4 3. 1 2 1 3 4 3 is the first example that's given to us. Yes. And k is equal to 3. What does k equal to 3 mean? We'll go through the array taking k elements at a time. Okay. Simple maths problem for you all. Okay. There are n elements. Let's say there are n elements. And when I give you maths problem, always have pen paper with you. Right? So keep one pen paper notebook with you. Okay. So let's say there are n elements. Okay. And I want to select k at a time, but not any k, like k in order. Right. So if I say 3 elements, which index will you choose? First 3 elements. What are the indexes? 0, 1, 2. Then the next window will be 1, 2, 3. Then after that 2, 3, 4. So if there are n elements, how many such windows will exist? If there are n elements, how many such windows will exist? Think. K is, let's say, 3. N minus 2. Okay. Why n minus 2? Simple thing is, first window will start from which index? 0 index. Second window will start from 1. Third window will start from 2. Which will be the last window? What's going to be the last window? N minus. What is the start point of the last window? Start point of last window. No, start point, not end point. N minus 3. Okay, again, let's say there is a size of, let's say n is there and size is 3. Okay, first window will start from here, right? 0, 1, 2. This will be the first window. Next window will be this one, right? Third window will be this. Fourth window will be this. Assume n was further. There is further along here. What I'm trying to say is, what is going to be the start point? If k is 3, can I start from here? Is there any elements to the right side to start from here? No, right? Can I start from here? No. Can I start from here? Yes. So when k is 3, I can start at n minus 3. Okay. If I don't know k, where will I start from? Means k is given, we don't know, it's k is 3 or 5 or whatever. So what's the formula for what's the start point of k? What's the last start point of the windows? N minus k will be the last start point. Okay. So what are all the start points right now? 0 is the first start point, right? Then 1, 2, 3, 4, so on till n minus k. So how many total start points we had? N minus, but we plus, because we started from 0. Remember this, right? So let's say k is 4. Okay, let's say k is 4. Okay, 0, 1, 2, 3, so on till n minus, and k is 4. So on till n minus 4. So 1, 2, 3, 4, 5, 6, all till n minus 4. This is there. Plus 1, which one? 0 is also there, right? 0 is also starting point. So total windows you are going to have how many? N minus k plus 1 window. Okay, that's why the question says, formally return an array of size n minus k plus 1, which what it's saying is, in each window how many distinct elements are there? So if I take a window of 3, 1, 2, 1, how many distinct elements are there in this? 2. Only 1 and 2, correct. In this one, how many distinct elements? Very good. Here, very good. Here, 2. Any more windows are there? No, that's it, right? So the output that is going to come is 2, 3, 3, 2. Totally, these are the number of elements here are going to be the number of windows, right? So n minus k plus 1 elements you are going to get over there. All right? Okay. So how do we do this one? Any thoughts? People who completed, you can just tell me, just very casually, what is the approach to solve this? Anybody got any idea how we'll do it? Check with index. Very good. Yeah, we'll start with the indexes. We'll go through indexes only, because there is going to be a start point. We are always going to look at a start point. So for example, for start in range, and I think this B is actually supposed to be k. A is the array. Alright. So I'll start from len A. This is going to be my start point. Are all the indexes of A going to be my start point? No. What are all the possible start points I have? 0 to n minus k plus 1. But what is this doing? It is generating all start points from 0 to till end of the array is n minus 1. I don't want till n minus 1, I want till n minus k plus 1. So len of A is n. Okay, len of A is n minus, one second, yeah, just let me see. All right, minus B. Okay, so if I do plus 1 like this, I want to include n minus k plus 1 index. No, correct. So this will be right. Yeah. Okay, this n minus k plus 1 is the start point. N minus k plus 1, these are all the start point. Okay, very good. So this is my start point. How do I get a window slicing? Very good. So I will say window is equal to, how do I get the window? A of, so there's no I here, star 2, very good, start plus B, very nice, right? B here is K basically, right? So from start till start plus B. So what we are doing is we are taking K elements. What did the question say we have to do? Distinct elements. How do I find the distinct elements here? Very good. If I convert this to a set, what will happen? Removed, right? Do I want only the unique elements? What do I want here? Do I want, like when I do 1 to 1, I want count, length, right? So what I want is actually len of set of window. What to do with this len of set of window? Has to be further added into an array. This is my final answer, 2, 3, 3, 2. So this 2 is what? Is the length of that set of that window, right? So I got the length of the set of the window. What am I going to do now? I will store it into an array. So let's say that array over here, initially I defined it as answer is equal to like this, okay, and I should append it, okay. You can write this in 3 steps also, okay. You can say elements is equal to, or rather distinct is equal to set of window, number of elements is equal to len of set of window, and then answer dot append. I just wrote it in one line, right? But you can write it, you're all following, no? But right, should I write it in multiple lines? You understood, right, what's happening here? Okay. Then we need to return this answer. That's all. Okay. It passes the test cases. Again, what happened here? We first took this as the start point, sliced 3 elements, found out how many unique elements are there, appended that to our list 2, then went on to 2, 1, 3, find out how many duplicate elements are there, appended that to our list 3, then went to 1, 3, 4, found out how many unique elements are there, how many are there, 3, appended that here, then 3, 4, 3, 2, appended it here. Same thing here, 1, 1, 1, window of size, what is the size here? 100. 100 is huge over here, right? So what's basically happening here is it's not returning anything. There is no window only, right? What about this case? Size of 4. So how many distinct elements here? 1. In the next window also 1, and here also 1. Okay. And let's submit it. Okay. Clear, everybody? Just you can take the code if you want to. You can type it. You can submit it now if you want to. Let me know when you're done. Stores with same items and different prices. Again, this is again typical type of question. Now you're given 2 stores or 2 lists, right? Here the list is code, mode, and here prices are 3, 2, 1. So the price of code over here is 3, code over here is 2, and mode here is 1. In this one, the price of this is 4, this is 2, mode is 2, and load is 2. Okay. The question says these are 2 different stores. All right, there are 2 different stores. You also go to 2 different stores. You'll go to Amazon, you'll go to Flipkart, see where the prices are different. You'll go for the cheaper price. Same thing here. You go to the 2 different store and you try to find out which items are having different prices, and you're supposed to count the items which are having different prices. Okay. So one way to do it, if you want to do dictionary, it's a very long process. If you want to do without dictionary, how will that be? Is you will check this, you'll check its price here. Okay. What you'll do, you'll check, okay, a name of 0 is code, a price of 0 is 3, right? So you check, okay, this is the case. Now then you'll find out what is the index of code over here. Okay, you'll try to find out the index of code. You'll find out that, okay, index of code here is 0, so you'll find out the price as 4, and then you'll say, okay, they are different. Then again you'll go to Ford over here, you say that its index is 1, You'll again find the index over here, and you'll again repeat the same process, right? Now, in this example, it so happens that they are all having same indexes, but it is not necessary. They may have different indexes. Okay, so this is one way of doing with lists only, but that is problematic. Why? When you are searching for code over here, you have to search the entire list, right, to find it. Now you'll say, sir, I will use in keyword. Even in keyword is doing the entire list searching. Okay, this is very important from interview point of view. If I say this code and I say find out the index of code over here in a list, if I use the in keyword, if code in bname, if I do that, right, or if I do code uh, uh, sorry, if I do bname dot index of code, you know the dot index keyword in list, it will give you the index of that element. If I do the dot index also, again what Python is going to do, Python is going to go through the entire list and find out what is the index. Now for each element over here, it's going to go and do that thing. Okay, example I can give you is, imagine you're trying to buy some chips from one store. You go to that store and you say, okay, what is the price of this chips in that other market? So your friend will go search entire other market and then say, okay, I got the chips. Then you'd say, okay, let me check for the other chips. So you went to other kurkure. You bought kurkure. Again, your friend is going and searching entire market, second one, and finding out what's the price of kurkure. Okay. But if we do using dictionary, what do I do by dictionary? I'll say, let's create a dictionary which says, which code is the key. Code will be the key, value will be 3. Ford is key, value will be 2. Mode is key, value will be 1. Okay, so let's say I take that as a dictionary. And again, here also I take a dictionary. In dictionary, when I say, okay, what is the value of code over here? It's 3. When I ask for value of code over here, it's not going to search the entire dictionary, because it is, the index itself is code over there. So for dictionary, it uses something called hashing, and over there searching is much faster. You don't have to search entire dictionary. You just look up the keyword code and it will get it. Okay, it's like saying, when you go to the market and you say, okay, don't search the entire market, just go directly to chip section, right? In chip section, is it there or not? In that way, it can be searched. So what we'll do is, we'll first create dictionary out of both of them. Okay, and let's say let's say store A is a dictionary and store B is also a dictionary over here. What I'll go is, I'll go for I in range len of, let's say, A name. I'll go through A. Right? That's what it is, A name. I'll go through A. I'll say key is equal to, or rather simply, store A of, what will be the key? What will be the key for this? What did we say? We are going to create a key value pair from this to this. So what's going to be the key over here? Code. How do I get that code? How do I get that value here? A name of, very nice. A name of I will be the key. What is its value? A price of, very nice. Okay. So we are getting the A price of I like this. Right. Similarly, I'll say for I in range len of B name. Okay. And I'll say store B of B name of I is equal to B price of I. Okay. So now I got both the stores. Right? We'll actually just print also, just to see. I always like to do this just to see if I'm on track. Right, so let's print both the stores. What we got here? We got the both stores, right? Code 3, code 4, code 4, and so on, right? So we're getting the entire store over here as we are needing it. Okay. So we got the stores. The question is, how many items are there which are there in both the lists? How many items are there which are there in both the lists, but the price is different? Okay. So what I'll do is, I'll go through one of the stores. I don't need to go to both of them. I just need to go through one of the store. I'll check, is this element's price here different from the element's price in other store. Okay, so for example, if I go for, let's say, a key in store A. Okay, I'll go through store A and I'll say, okay, price A is equal to, not price A, let me not do that, or let's just say current price is equal to store A of key, right? For whatever is that product over there, I got its price. Now I need to find two things. One, does this product even exist in store B? And if it does exist, is the price different? Okay, so how do I check if it exists in store B or not? I'll check if key in store B. This is what I was talking about. When you do this, it's searching in a dictionary. Searching in a dictionary is much faster. It's very fast. But if this was a list, it will take long time. Okay, so if key in store, okay, if the key is there in store B, then what do I need to check? And so I'll say if current price not equal to store of B of key. Okay. If this is not the case, I'll say count is equal to count plus 1, and here we should keep a count variable also. Count is equal to 0 initially. All right, and we have to return or print here. Yeah, return. So I'll say return count. Okay, so it works over here, but let's make it a little bit better. Okay, usually speaking, this kind of that kind of nested is not a good idea. All right, so usually speaking, it's not a good idea to keep completely nested like that. Okay, so what I'll do is I'll just simply put an AND over there. Okay, so all I did was there were two if conditions, right? I made first condition as if that key is in store B, and instead of doing inside that if condition, I did and that store B of key price is different from store A of key, right? Then we do a count is equal to count plus 1. Now I will say, sir, how it will check if the key is not there? How is it checking for price? Right? If it is there, it's fine, but if it's not there, then the next condition will give us error, right? Because that key is not there. So again, want to introduce you to one property of Python. In an AND condition, if let's say you have an AND condition, let's say you have something like condition 1 and condition 2 and condition 3. If condition 1 is false, automatically condition 2 and condition 3 will not be evaluated also in Python. Okay, so for example, you are checking, is this element present, and the value of this element is so and so. Now if element is not present, second one will give you error, right? Because element is not there, how can you check? But that's why if the element is not present, first one will become false altogether. So the second part automatically is not evaluated. Okay, so all right, let's go to the last question of the practice question. Canvas frames, right? So this is a little bit more tricky. Yeah, just don't want to touch that. Yeah. All right, so the question is like this. Okay, you are given bunch of sticks. Okay, in the question you are given bunch of sticks and you're supposed to form frame. Everybody's read the question? Okay, just once read the question also, read it properly. Always try to visualize the question first. Don't go directly to Python or anything. First try to understand the logic of the question. Okay, so you are given bunch of sticks, right? Let's say for example, you are given 3 sticks. Let's say this is one stick, this is another stick, this is another stick. Okay, and this stick length is 1, 1 and 2. Okay, what you're supposed to do is form a frame. Frame, like for example, look at this window. There's a frame, right, around it. Yeah, so what happens in this? It's a rectangle. You can make a frame either rectangle or square. It's saying in rectangle, what needs to happen? Opposite sides are equal. Okay, can I form a frame with these 3 sticks? Why? 3 sticks you can't form. How many I need? 4. Okay, can I form a frame with a stick and length here is 3? Why? Opposite side has to be equal. If I try to even do it, I'll get like this, like this. So I'll get probably, this will be 2, this will be 3, and these two can be 1. Okay, let's say, right? This becomes what, rhombus or something, right? What is it called? Trapezium. Yeah. The difference between trapezium and rhombus, by the way, what's the difference? Rhombus, all sides are equal. Okay. All right. So we already established some things. What have we established? We need at least 4 sticks to form a frame. That's number 1. Number 2 is we need opposite sides to be equal. Now the question is saying, how many frames can you form? How many frames can you form? It is not necessary to use all the frames, and you can't break any sticks. For example, if I give you another stick of size 3, now can we form a frame? How many frames? 1 frame, correct? What will be that? It will be like this. 1, 1, 3, 3, right? So that's what you're going to get. We will leave out 1 stick. 2 will be left out, which is fine. Question is not saying you have to use all the sticks. Not there. Okay. Now the question is saying, how many frames can you form? Question does not care whether those frames are of big area or small area. Okay. For example, let's say you had another one here, 2. How many frames can you form right now? 1 frame or 2 frames? Okay. You can form 3, 3, 1, 1, or you can do 1, 1, 2, 2, or 2, 2, 3, 3. Now, don't go by the drawing, right? This is not 1, 1, 2, 2, obviously. But what I'm saying is, it's either of these can be formed. Okay. Question does not care which one you form. For example, if you form this one, the area is some 3 square units, right? This will be probably 2 square units. This will be 6 square units. It doesn't care about the area. It's not saying you have to form this one or that one or something. It's simply saying form. How many can you form maximum from this? 1. Either you do this arrangement or this arrangement or this arrangement, but you can form maximum 1. Okay. Now, the question is saying, given a bunch of sticks, like in this case, I gave you a bunch of sticks, you said 1 is possible. Given a bunch of sticks, find out the maximum number of frames we can make. Okay. Try it out. Don't go for the code, I want the logic first. Alright. So try, think. I can give you the logic in 2 minutes. If you don't think, then you will not come to know. So take 2-3 minutes, discuss amongst yourselves if it's fine. I will not say don't talk. Discuss amongst yourselves. It's completely okay to discuss.
So if the count is greater than 2, we'll keep on increasing. For example, we'll consider a variable named as a, and if there are 2 variables which are greater than 2, which has frequency of greater than 2, then we'll increase the count of a. If the count of a is 2, then we'll increase the count of frames.
Okay. So let's take this example only. You are given, let's say 1, 1, 2, 2, 3, 3. All right. So in this case, what were you saying? 1, 1, 2, 2, 3, 3. Let's say it's given. Okay. So yes. Okay. 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 Very good. Very good. Actually, it's almost the correct answer. One thing I will suggest here is, don't just say a value. What is a value suggesting? A value is counting number of especially, yeah, same elements, right? And you said one thing very nice. You said when a becomes 2, right, is when we increase. So first what you said is, first I'll count if a, right? So let's say for example there is this 1, 1, and let's say there was 4 at the start, right? What do I, so let's say I count this 4 I got is 1 element. What do I do with this 4 then? Leave it, right? So okay, 4 is just 1, leave it. You go to the next one. Because this is 2, so that's why we made a is equal to 1. You are seeing. right? Then I again found this is again 1. So now you made this as 2. The moment this reaches 2, you know you made 1 frame. Okay, got it. Let me put in better words. Sit down, your name. Okay, so Suchitra, very nice, super answer. Let me put into better words what she's saying. Okay, first things first. When do we form a frame? When can a frame form? When height and width are same. Very good. Not height and width actually. Uh, Opposite sides are same. Meaning I need at least 2 pairs. Right? If I have just 2 sticks, I can't form a frame. I need 4 sticks. But any 4 sticks is possible? No. Very specifically requirement is 2 pairs of sticks are required. Right? Okay. Now, does it matter what is the size of the frame? Did we say it matters? No. So, if example, I tell you that, so we'll remove this. Okay. Let's say I tell you there is 1 pair only. How many sticks are there? If there is 1 pair, how many sticks are there? 2 sticks are there. Very good. So I say pairs. Let's say I say pairs. Let's say there is only 1 pair. How many frame you can form? Right? I can form 0 frames. The moment I have 2 pairs, how many frames I can form? I can form 1 frame. When I have 3 pairs, still 1. 4 pairs, 2. Okay. Now, when I say 4 pairs, what does that mean? It could mean that I have, let's say, is this 4 pairs? Yes? 1, 2, 3, 4. This is 4 pairs. Right? This is one way of thinking of it. Look at this also. Is this 4 pairs? No, right? Yeah. 1 second. All right. Let's say if this is now 4 pairs, right? How? 7, 7 is 1, 9, 9 is 1, 8, 8 is 1, 4, 4 is 1, right? It doesn't matter if they're all equal or what. I just need 4 pairs. If I have 4 pairs, then 2 frames can form. Okay. So what I need to do is find out how many pairs are there. Okay. Now we saw earlier how to count the number of elements, frequency of elements we saw, but we didn't see how to count frequency of pairs. Okay. All right. Let's make this frequency over here. All right. Yeah. Let's make the frequency over here, and I'll just add a few another elements so that we can see. All right. How many pairs are there here? So 5 forms 9 and 9 forms. That's it. Only 2 pairs. Right? Okay. How will we get that? Let's get the frequency of this. 5 is how many elements? 3 elements. Okay. 9 is 3 elements. 1. Okay. From this, can I find out how many pairs are there? Yeah. So from 5, from 3, I can say there is 1 pair. And here I can say 1 pair. All right. Let's say this 9 was occurring 7 times. How many pairs are there? 3 pairs are there. Right. So now it will become 3 pairs. If 9 was occurring 7 times. Okay. This we know how to form. Right. We just saw how to do this. How do I get the pairs but from that? Like 3 is having 1 pair. 7 means 3 pairs. How do I get the pairs? Divide by 2. Integer division by 2. So first I should get the frequency. From the frequency, what will I find out? How many pairs are there? So now let's say I found 1 pair plus 3 pairs. How many total pairs are there? 4 pairs. So I'll say, okay, there are 4 pairs over here. The question is asking how many pairs we need. Is that the question? No. What is the question? How many frames? So how many frames will we have? 2 frames. Very good. Because 4 pairs, 2 frames. Let's say there were 2 pairs here. Let's say I had 5 pairs. Then how many frames? Again, 2 frames. Okay, as per this. So the question is all about counting frequency. That's all it is about. First count the frequency of elements. First count the frequency of elements. Then count how many pairs are there. And then finally count how many frames are there. So frequency of elements we know. So for example, I do frequency is equal to this, right? I'll go through all the elements in A. So I'll say for stick in A, frequency of stick, sorry, if stick in frequency, then what do I do? If the stick already exists in frequency, then what to do? I'm counting the frequency of each stick, that part. So if stick is already in frequency, then what to do? Increase by 1, very good. Else, if it's not occurred so far, then what to do? Frequency of stick equals to 1. Okay, I got all the frequency of each stick. Now I need to find out how many pairs are there. So I'll say, okay, for key in A, and I'll keep here pairs is equal to 0. I go through all the keys. How do I find out the number of pairs, everyone? By 2, right? So I'll say, all right, let's say value is equal to A of, frequency of, no, key in frequency, sorry, key in frequency. Value is equal to frequency of key. And what will I say? I'll say current pairs. So the pairs of this particular stick, right, is equal to value divided by 2. This is this step, everybody, where I find out that 5 has 3, 9 has 7. So what am I doing? I'm saying, okay, get 5, it has 3, divide by 2 will give me the pairs of 5. So to get the total pairs, what should I do? I should say, all right, pairs is equal to pairs plus current pairs. Okay, now I got total number of pairs. But for the question, what do I need? Frames. How much will be the frames? Pairs by 2. So frames will be equal to pairs divided by 2. We have to return, right? I think. Yeah. You can take this code. Do remember all of this. This will be helpful for you during your placement time as well as in the project. Okay. More than the dictionaries and sets part, it is how we are thinking about the question and how we are thinking, breaking down into steps. All right. Think of that part. All right. So we have very little time right now. I think we have till 12. Do you all have immediately class after this or something? You have a class after this at 12? All right. Okay. So what I want you all to do is, meanwhile, 1 second. I want you all to go to collab.research.com. It is, it's Google's thing. collab.research.google.com. Okay, I'll just write it also here. But if you just search Google Colab, COLAB, Google Colab, right? I want you to go there and create a new notebook. Create a new notebook. Click this button, new notebook below. All right. So again, I'll just show you all again. You just go Google Colab. Just search for this. Google Colab. Search for it. The first link that comes. Welcome to Collaboratory. Anybody used this before? You used, right? Okay, very good. So go click new notebook over here. Okay. And you can rename your notebook to, let's say, I'll just say it, NumPy. Okay. What is this? Everyone, it's a notebook. Anybody seen? You must have used Jupyter Notebook before, right? This is online version of that. You can use Jupyter version, Jupyter Notebook also. That's also fine. You don't need to use this one. Choose the one you are most comfortable with. Okay. Very simply, I'll just take about 5-10 minutes more. That's it, and then I'll leave you all. this, the way notebooks work is, this is something called as a cell. Each cell is executed independently. It's very useful for us when we are doing data science projects, because we are always doing in bits and pieces. So for example, some of you will be doing house price prediction. When you are doing house price prediction, first you will take the data set. You will read the data set. When you are reading the data set, you will first try to find out what are the columns in the data set, what are the values. So before even writing the full program, you will just want to explore a little bit. Here you will run the program and you will get to see some exploration. After that, you will write the proper program. Okay, there's a lot of uses of this notebook. Now our main task is going to be about NumPy. So NumPy and Pandas are two libraries of Python that is almost always used with data science. What we'll do is we'll import the NumPy libraries, and usually as per convention we import like this: import NumPy as NP. As per convention, this is what we do. Okay, so now that NP is having the NumPy library. Okay, we'll not go into too much detail. I know we have less time. Just let it run it fully. Major use of NumPy comes with something called as the NumPy array. Right. So far we used lists. Right. In Python we use lists, but lists is not as fast and it's not as powerful, especially when we're doing data science stuff. Okay. So we are going to use the NumPy arrays. Now the NumPy arrays, what's the good thing about that? So let's say for example I have a list, right, and I have a list of marks. Okay, so marks is equal to, let's say I have some, right, let's say I have something like this. Okay, so and I'll just run it also. How did I run it quickly? If you just press Alt Enter, it will execute and go to next line. If you press Control Enter, it will just execute but will not go to next line. Okay, so this is the marks, but this is a list. Okay, how many elements are there in this list? If I just do len of marks, it will tell me there are some 10 elements in the list. Now if I want to convert this to a NumPy array, okay, I'll say ARR is equal to np dot array of marks. Okay, so now it's stored in that. I'll just run it again. It's stored in this array. Right? So now if I actually run this array over here and do this, I'll get that you see this, I'm not getting a list, I'm getting an array. This is NP array here. Okay, now what's the advantages of this? Well, number one, let's say for example you had another one. Let's say I had marks 2. Let's say first of all I had marks 2, and the numbers were a little bit different. Okay, something like this, and I'll just say np dot array again, or I'd say array 2 is equal to np dot array. Okay, so now you have two arrays, ARR and ARR2. Now the beauty of this is if I do ARR plus ARR2, if I did something like this, what it will do is it will actually do the summation of it. If you were to do this with normal lists, it's going to concatenate the two lists, but here it's actually going to sum it. Why is it doing this? Because this is used more for mathematical purposes. Okay, so when you do plus, it's like this. If you do multiplication, it will actually multiply the two arrays. Now remember, this result is not being stored anywhere because we are just outputting the result. We are not storing it into another array. If you want to store it, you have to do equal to array into array, ARR into ARR2, like that. Okay, now other benefits of that, so let's go back to our original array like this. Other benefits are, this comes automatically with a bunch of functions. For example, I can do dot mean, it will give you the average of it. Okay, if I do dot max, it will give me the maximum number of it, which is 99. If I do again dot min, it will give me the minimum number of it. All right, if I do, let's say, dot size, right, I'm going to, no, not sure, size is not there. Second, yeah, size is not a function, size is just a property over there. Okay, if I do dot sum, I'm going to get sum of all of the elements. Okay, these are, now you'll say, sir, in lists also we had something like this, right? Yes, you had something like that in lists, but this becomes very powerful. You just, as you keep using it, you'll see that it becomes very powerful. So for example, okay, I'll not go into the condition and all of that. What I want you all to do, because we are already out of time, but what I want you all to do is, when you go to the next module, you just go here and go to the next module. As a homework before tomorrow's class, make sure you watch all the tutorials. Only asking to watch the tutorials, not asking you to complete any questions or anything. If you are able to solve the questions after this over here, exercise 1 and exercise 2, very good. Okay, but without fail, watch all of the tutorials and come. Okay, watch all the tutorials and come, and then we'll solve these two questions in the class. If you're able to solve it, very nice. Okay, so please take this up, and we'll start with this NumPy tomorrow, and then we'll complete pandas, and if time permits, we'll also look at EDA, exploratory data analysis, is what we'll also check out. All right, everybody? Okay. Yeah, I think so. Do I have some more time, or is it like, do you all have to go to class right now? Can continue? Okay, how much? 10 minutes more, or what? Yeah, up to 12:30 you can continue. Okay, very good. All right. So yeah, in that case, let's go over uh, some of the basics of that. Okay, so we'll go through some of the syntax of it. Um, 1 second. Yeah, these are all. You guys check this. All right, that is there. Yep, yep, yep. We just see that multi-dimensional. Okay. All right. Okay, everyone. So we'll go step by step on this. We'll look at. You can also follow along. You can open this one along with me. NumPy operations over 1D array. Okay, we'll go step by step on each one of them, and as and when there's an edge case, I'll tell you. So this is basically, you're given a data set called heights. If you open NumPy operations over 1D array, we'll go through all of them. Okay, so you're given something called heights. Heights is this a list or a NumPy array? List, correct? So the only square brackets here. You convert that to a NumPy array over here. Okay, now you'll have a bunch of questions. Count the number of participants of the people of the heights. Count number of participants. We already saw this. How do you get it? You can either do length of heights, or you can do dot size. Okay, the dot size one, you can do it. Okay, convert the heights from inches into meters. How do you do that? So we'll go step by step here. 1 second. And let's say these are the heights given to you. Okay, these are the heights, and we just convert that heights into a, let's say, NumPy array. Okay, now I want to count how many elements are there. How do I do it? I'll say heights dot size. Okay, it'll tell me how many elements are there. Very good. Now I want to convert. So there seems to be 1015, a huge thing. Okay, and if I did len of heights, also we should ideally get the same thing. Yeah, so 1015 elements are there. Okay, next, what did we say? We want to convert all of the inches to meters, right? How do you do that? They've given us the formula. They've said you can convert inches to meter by actually multiplying into 0.0254. So as we said, heights into 0.0254 will automatically apply to the entire array. Now in lists, you would have to actually write a for loop and multiply each element. But in NumPy arrays, it just gets applied to the entire array. Okay, very nice. Next, convert a list of weights in LBS. LBS is pounds. Okay, so a list is is given. convert it to kg and calculate BMI. Okay. Now, how to convert pounds to kg? So again, they've given us the weights here. You're supposed to we'll just take that weights also over here. 1 second. We'll store this, let's say, as heights underscore. We said it wanted to convert to inches, right? The first one was inches to meters. Okay. So we'll just make this as meters is equal to this. So 1 second. Yeah. So that's your heights over there, and then we are given weights also. So we'll just look at the weights. These are the weights given in pounds. All right, and we'll convert this also to a numpy array. So weights underscore LB is equal to numpy dot array weights underscore LB. Okay, so we got this. Now it's saying convert this to kg. So I'll say weights of kg is equal to weights of LB into something. What is that into something? We'll come to know that. They have given here into this 0.453592. So this is the weights in kg. So I got the weights in kg. Now I got the heights in meters. I got the weights in kg. I have to calculate BMI. Anybody heard of BMI? Body mass index. Okay. What is the formula of BMI? I think it's height square divided or kg divided by height square or something, right? We'll see over here. Yeah, kg divided by height square. So whatever your weight is divided by height square. So I'll say BMI is equal to weights underscore kg divided by heights underscore meters square. Now again, the best part about this is it applies to the entire array. You don't have to worry about doing for loop and so on. It applies to the entire array over here. So let's just see. And if I do BMI now, so I got the BMI of all the people over here. Okay, 23, 27 point something, 28 point something, 25 point something. Okay. What is a healthy BMI? Anybody knows? Generally, they say between 20 and 25 is good. Anything less than 20 means you are undernourished. You don't have enough nourishment. And above 25, there's a chance you can go to obesity. Right? So go home and check your BMI, everyone. Right? You're all young. You can improve your BMI. Okay. All right. Now this is the interesting part. This thing is called subsetting the arrays, which is nothing but slicing. Now the interesting thing about NumPy arrays is that it's not just about, for example, if I look at this, BMI over here, right? How many elements will I have in this BMI? 10, 1015 or whatever what we have. Basically the same number, right? It's the same heights divided by same weight, so the number is going to be the same. If I do BMI dot size, I'll get the same thing here, which is 1015. Okay, that is good. But if I want, let's say, the first 5, so I'll do BMI like this, 0 to 5 or just colon 5. This is slicing. Slicing works. Slicing still works in, yeah. So slicing still works in NumPy array. This is there. This is a normal one. The interesting slicing here is called conditional subsetting, where you can actually give a particular condition to it. Okay. For example, we are talking about this BMI. And what did I tell you about BMI? What's a healthy thing? 20 to 25. Okay. Now let's say we want to find out how many people are there less than 20, undernourished, let's say. So I'll say BMI, and in this square bracket I will put condition BMI less than 20. This is not available to us in lists, but here we are getting that we have only one person, 19.49 is that person's BMI. Okay, so one person is undernourished. If I have to get overnourished, I don't think there's overnourished, it's obese only. So 1 second. Right? If I run this, right? So a lot of people are there having junk food, I guess. Okay. So how do I find out how many people are there though? dot size, because this output also is another numpy array only. Okay, so I can do dot size. So out of the 1015680 people are good, they're having fun, right? Anyway, so they're a bit obese over there. All right, so that's one. Okay, I think otherwise we've covered all of it. Fair enough. Okay. And we can find of the people who are above average or above 25, what is their mean as well. So the people who are obese, generally how much obese are they? So they're having about 27. Okay. Now the thing about mean is that mean is not a good indicator or sometimes. So there are three aggregate functions you should all know from data science perspective. What are the three? Anybody knows? Mean, median, mode. Very good. So there's mean, median, mode. What is mean? We know is the sum of all elements divided by number of elements. Okay. What is median? Middle element. If you put all of them in sorted order, the middle element. And mode is most occurring element, right? Now different kind of data requires different kind of aggregate functions. These are all called aggregate functions, and different data requires different one of them. Okay, let's look at an example. Did I cover mean, median, mode with you earlier? Because I've covered with, I think, your junior batch. That's fine. Let's look at one example. Okay, let's say there are a bunch of people. Okay, and let's look at placements. Right. So let's say there's a college and they're marketing placements. Okay. Now in that we are saying that 3 students got, let's say, 3 LP, or let's say 5 students got 3 LP. All right, so there are 5 students here who got 3 LP. One student got about, let's say, 25 LP. Okay, one student got that. So how many students are there? 6 students are there. Okay, so there are 6 students. What is the mean right now over here? Let's don't do all this mental gymnastics. We can do. This is how many? This is 15 plus 25 divided by 6. This is equal to 40 divided by 6, which is equal to 6 point, let's say 6. So now there is one college or something, they go and advertise 6.67 LPA is the average package. But is that accurate representation? Why? Because most people are getting 3. In fact, if you were to randomly choose one person from this, you will most likely find 3, which is half of the average here, right? Less than half of the average. You get what I'm saying? If I do take median, what will I get? Is equal to 3, right? Okay. And mode also will be 3. In the scenarios where the distribution is uneven, meaning that there are certain extreme events, in those scenarios averages does not work well, because the extreme, what will it do? It will overshadow the other elements. Okay, so for example, let's say I take all of your heights and I'm trying to take an average. In the worst case scenario, who's the tallest person that you can think of that you have met? What is their height? Tallest person, 6'5", 6'6", let's say it's a giant, 7, right? It's the shortest person you have seen, 3, 4, let's say, right? So your entire range is between 4 to 7, correct? You'll fit in so many people here, but even if you take average, let's say there are 7, okay? So let's say it's something like 7, 7, 4, 4. What will be the average of this? 5 point. So it will be 8 plus 14. 14 is 8 plus 14 is 22. 22 divided by 4. So it will be 5.5. Okay, let's say. Okay. Now these are two extremes here. Imagine if I put some average people also here. Right? So what average height will be about 5.5 or something, right? 5.5 and let's say 5.6 or something like that, right? If I then took, let's put 5. Just put a 5.7 here. Okay. If I put these two also, Just use your calculator quickly and find out the average of this. So it will be 8, 14, 14 plus 11.25. So it will be 5.6. Okay. See, these are the average. Sorry, these are the extremes. Someone who's really short, someone who's really tall. But for the most part, most people you will find like this. Correct. In that case, average works well. Anything natural, generally speaking, like heights is natural, right? You will not have, for example, 25, 8 times the height of this, right? If you look at 20, if this was the distribution, you will actually have someone who is 8 times the size of somebody. Not possible, right? Usually it's like double the size at max. You'll never have triple, maybe even triple, right? If somebody is really like a dwarf, then you'll have a triple the size. But generally speaking, height, weight is another one. Okay. Yes, there might be someone who's like super obese, right? 150, 200 kg or something. But even if you take that one person and you take everybody else, the average will not move too much. It's not going to move that much. Versus over here, it can. So whenever you're using mean, median, mode, this is basically an interview question. So whenever you have extreme events in your data, mean is not a good idea. Okay. Median or mode is better in that scenario. Okay. All right. So yeah, we look at this question. We look at exercise number 1 now. Here, there are 2 arrays given to us. Okay, there are 2 arrays given to us, and you can go down and see also. There are actually 2 arrays. They have already made the 2 arrays into NumPy arrays. We just have to fill in the blanks. Okay, so 2 arrays are given to us. What we are supposed to do is, the first array contains the number of each product that were sold. For example, if array is 1 to 9, it means there is one quantity of product 1 that is sold. Product 2 was sold 2 times, and product 3 was sold 9 times. Very nice. Okay. The second array contains the cost of each product. So for example, if I just go here, okay. So let's say, for example, the cost of each product, let's say cost of 1 is 10, cost of 2 is 20, cost of 3 is 30, let's say. So I would have made how much money? 1 into 10, because I sold one item of 10. So 10 rupees plus 2 into 20 rupees, 40. So far how much I made? 10 plus 40, 50, plus 9 into 30, which is 270. 270 plus 50, 320. So totally I would make 320 rupees. Now let's go through the questions, and from what we learned of NumPy, we will be able to answer this. How many distinct products were sold totally? Distinct products. Very good. 3. Why? Because we know the number of, we know that, okay, maybe 1 to 9 is the quantity of each product, but the size of the array will give us the number of products. Correct? So if I want to find that here, that was just an example. Number of products. How do I find it out? Very good. Items sold. So this contains the quantity of each. But I don't care about quantity. I want to know how many elements were sold. So I'll say items sold dot size will give me the number of elements sold. I can also do len of items sold. Both are fine. Total sold. Sum of all the items sold. So I'll say items underscore sold dot sum. Very good. Average price. Okay, very good. You can do that also, or average price. This is, yeah, dot mean. So I can just say price dot mean. Yeah, I can do this. Price dot mean. Okay. Maximum price. Price dot max. Total revenue. This is what total revenue means. How much money I earned. So I in previous scenario scenario, how much I earned? I earned 320. Right? How do I calculate that? So I need to multiply items sold. Very good. So I'll say items underscore sold into price of each element. So now this will what will give me? It will give me another array only. It will give me basically 1 into 10, comma 2 into 20, comma 9 into 30. But I want to know, okay, This is on each item I made this. What's the total I made? Sum. Very good. So I need to take the sum of this. I'll do this dot sum. Okay. Expensive products. For expensive products, let's go here. An expensive product is one which has more price than the average price. So how do I do that? I want to find out the number of products. How many expensive products are there? I want to find the number of products whose price is greater than average price. How do I do that? I say is equal to price such that price is greater than average underscore price. We are using that conditional thing over here. Let's see if this is correct or not. Okay, we are making some mistakes here. We'll go through each mistake one by one. Okay, let's look at that. The last one is the issue. So why is this not scrolling horizontally? Okay, the last one is the issue. Yeah, we are not supposed to give. We are supposed to give number of expensive products, not the price of each expensive product. So I'll just do dot size over here. Okay, still it's not working. What is the issue? In the case of average, I'm not supposed to give any decimal. So you will not be able to see it's here. But in the case of average, I should not be giving any decimal. How do I do that? How do I convert decimal to integer? Int of, very good. So I'll just do int of price of mean. Now it works, and if I submit it, it will work. Okay. So simple NumPy exercise. You just have to know the basic NumPy formulas, right? So just fill it, submit it,